In this video I'm going to explain how to solve a limit when you have a piecewise function. Here I have my super nice piecewise function called f of x in here, and simply in two pieces, which is these two here. And I have here my goal, which is I'm required to find the limit when x approaches to 2. Now here the first thing would be as you have a big picture of how this f(x) behaves in a graph. How would it behave in a graph? I'm going to use a quick tool here. I'm just going to do this. I'm going to draw a line here. Here, this line goes from negative infinite to positive infinite. I'm going to place here, as we can see, that this f of x is split in two pieces, and they're all are around the number 2. There's a piece before and after the number 2, so I'm going to place here the number 2. And now here comes the thing. I have to identify which function describes which statement describes the f of x in which section of this, after and before the number 2. So you can see here, for all the x's below or lesser than number 2, we use this statement here. So I'm going to place it literally after the 2. Before the 2, be here x minus 2 the square. That is to say that no matter how or where the f of x, as long as it's lesser than number 2, it will behave like this, using this statement here. Now I'm going to, after the number 2, we'll be using this one here, 2 times x minus 4, because we can see it here from this condition here, 2 times x minus 4. Now, I want to notice something. We are trying to find a limit. We are not actually concerned to what is actually the value of f of 2. The value of f of 2, we will find it through here, because here we have a greater or equal. We have to evaluate in here, but we are not required to find the value of f2. We're required to find a limit, which is not the same thing. Now, if we want to find the limit when f of x approaches to 2, we have to get closer and closer to the 2 from the right and from the left, and see if we get to the same value. Well, basically, that is to say, we have to split this limit of f of x when x approaches 2 in two pieces. So we have to calculate here we have to find the limit when x approaches to 2 from the left, and we have to calculate as well the limit when x approaches to 2 from the right of f of x. Now if they get to the same value, then we could say that the limit exists here. In either case, the limit will not exist. So, well, basically what I'm saying here is that if you calculate the limit from the left of this 2 for f of x, and if you calculate the limit from the right of 2 for f of x, we should be sure to get to the value of the limit of f of x when x approaches to 2. Or if they do not meet, if they're different, there's something like this, then the limit will not exist. So let's get to find these two, the green and the blue one. As you can see here from the graph, if we approach from the left, using here this x approaches 2 from the left, we will require to be using this piece of the function here, the x minus 2 squared. And if we are approaching from the right, approaching to number 2 from the right, we would have to use this piece here, because this one is literally on the right side of the number 2, and the other one it's literally on the left side of number 2. So I'm going to get them just separately and see what we find. I'm start with the green one here. The limit when x approaches to 2 from the left for f of x, I'm going to directly write the statement here, this one here, and we can just substitute right away the number 2 here. We can see we won't be getting an undefined here, so I'm going to substitute directly. So it will be, well, 2 minus 2, the square, that will be a 0, so we get at the end a 0 here. So the limit when x approaches to 2 from the left, it's equal to 0. Now I'm going to find the other one, limit when x approaches to from the right. Now I'm going directly to use this piece here, this 2 times x minus 4. So I'm going to, we can see that we won't get an undefined, so I'm going to directly substitute the 2 here. So it will be 2 times 2 minus 4. That will be 4 minus 4, and we get as well a 0. Now we can see at this limit from the left and from the right, we can now say that they are equal. And as they are equal, then the final limit, when x approaches to 2 for f of x, it will be actually the value they share, which is 0 here. Oh, this is too ugly. There we go. And that would be it with this video.